I welcome you all once again to another video lesson for class 9 physics. The topic of discussion for today is going to be Archimedes Principle and flotation. Let's begin today's lesson with knowing what is buoyancy and buoyant force. Now, this particular property of buoyancy is observed in fluids. Now, what are fluids? Liquids and gases, both are called fluids. Now, you might have observed that when you are immersing an object inside the surface of a liquid, there is some force applied on the object which always tries to push the object out of the liquid. Now, this particular force is actually applied by the liquid, or rather, this force is applied by every single fluid on an object which is being partly or completely immersed in it. So, we can say that the tendency of a fluid to exert an upward force on a body immersed partly or completely in it, is called buoyancy. Obviously, the upward force experienced by the body when immersed in a fluid is called buoyant force or upthrust. Why is it called upthrust? Because this particular force is acting perpendicular to the surface and always acts in the upward direction. So buoyant force is also called upthrust. Now an important question arises: what are the factors affecting buoyant force? Now the magnitude of the buoyant force is depending on some parameters. The first one being size or volume of the object immersed in the fluid. This means larger the size or volume of the body immersed in a fluid, the greater is the buoyant force or upthrust acting on it. Buoyant force or upthrust is actually directly proportional to the volume of the body immersed in a fluid. Next, it depends on density of the fluid on which the object has been immersed. So higher is the density of the fluid, greater will be the buoyant force. It is dependent upon acceleration due to gravity at a place. So it is directly proportional to acceleration due to gravity of that place. So a body, when immersed in the same liquid, will experience lesser buoyant force on the moon than on the earth, because the acceleration due to gravity on the moon is less than that on the surface of earth. Finally, buoyant force is inversely proportional to temperature. This is because temperature decreases density of the fluid. So these are the four factors that is going to bring about a change in the magnitude of buoyant force: size or volume of the object immersed in the fluid, density of the fluid, acceleration due to gravity at a place, and temperature. So obviously a question arises, what should be the magnitude of the buoyant force? Suppose if we consider an object that is immersed in a fluid completely, then what should be the resultant upward force exerted by the liquid on the block? So the answer for this is the resultant upward force exerted by the liquid on the block will be equal to mass of liquid displaced multiplied by acceleration due to gravity, or this can be written as weight of the liquid displaced by the block. Why does an object lose weight when immersed in a liquid? Suppose we consider this particular setup. There is a block which has been immersed in a liquid, and with the help of a spring balance we are measuring the weight. Roughly, if we consider this particular setup, so what are the forces acting on the object when it is immersed in the liquid? So obviously there are two forces. First of all, the weight of the object. The weight of the object is acting vertically downward, and the other force that is acting on the object is the upthrust applied by the liquid, or the buoyant force due to the liquid, which is acting vertically upward. Now if the tension in the string is T, that should be equal to the reading on the scale of the spring balance, then buoyant force plus tension on the string is equal to the true weight, that is W. So apparent weight will be equal to the reading on the spring balance, and that is actually the tension in the string, so that should be equal to W minus U. So obviously whenever an object is immersed in a liquid, a part of its weight gets balanced by the buoyant force or the upthrust, so there is an apparent loss in weight. Now this should be understood that the loss in weight of an object when immersed in water is the apparent loss in weight, because neither the object has lost any matter nor the gravity at that place has changed. This is only because of the fact that some amount of its weight has got balanced out with the buoyant force or the upthrust. That's why an object when immersed in a liquid appears to be lighter. Archimedes principle. Archimedes principle is also known as the law of buoyancy. Now this principle was discovered by Archimedes, who was a famous mathematician, physicist and philosopher. So what is Archimedes principle? When an object is immersed wholly or partly in a fluid, it experiences a buoyant force which is equal to the weight of the fluid displaced by it. Now, when an object is immersed wholly or partly in a fluid, it suffers an apparent loss in its weight. This apparent loss in the weight of the object is equal to the weight of the fluid displaced by it. Now, as you can see in the figure right now on your screen, if a setup like this is used, in the first case you are having a solid object A whose weight as measured by the spring balance is 67. Now there is an empty container whose weight is right now 6 gram as measured by the second spring balance. Now when the same solid A has been immersed in the liquid, it will occupy some space, and obviously in order to fit inside the liquid it will display certain amount of liquid that gets collected in that empty container. So now as soon as the solid has been immersed in the liquid, you find that there is an apparent loss in its weight. Now the measurement as recorded by the spring balance is 55. What about the liquid that has got collected in that empty container? Now the weight has changed to 18. So just add up the values in both the cases. In the first case, the object reading W1 was 67 and W2 was 6. So 67 plus 6 is 73. In the second case, when the same object has been immersed in liquid, the value is 55, and that recorded by the second spring balance for the displaced liquid is 18. So 55 plus 18 is again 73. So this is actually an experimental verification of Archimedes principle, which proves this fact that whenever an object is immersed partly or completely in a liquid, it experiences a buoyant force, due to which there is an apparent loss in its weight. And what is the value of the upthrust experienced by it? It is equal to the weight of the liquid displaced by that object. So this is the famous Archimedes principle. Now right now on your screen you can see some examples, or rather the applications of Archimedes principle. Archimedes principle finds its application in many places. The first one being a hydrometer. This is actually a lactometer. It finds its application in the designing of ships and submarines. Hydrometer is used to check the density of a liquid, while lactometer is used to check the purity of milk. Now, even designing of ships and submarines are done keeping in mind Archimedes principle. This actually can be explained easily by giving an answer to this question: why do objects float or sink in a liquid? A cork, when placed in water, rises and floats over the surface, whereas a stone or a piece of metal sinks to the bottom. What makes cork to float and stone to sink? So before finding an answer to this question, let us understand the various forces acting on an object when placed in a liquid. So obviously the forces are the weight W, which is always acting vertically downwards, and apart from the weight, the another force which acts on the object right now is the buoyant force applied by the fluid vertically upwards. So obviously there are three possibilities, as you can see in the picture right now coming on your screen. If suppose the buoyant force is not able to balance the weight, this means F is less than W. So what will happen? Since the downward force is greater than the upward force, then body will sink, as is the situation with an iron nail or a stone. Now come to the second figure. When buoyant force is equal to weight. So as the downward and the upward forces are equal, the body will just float along the surface of the liquid, as is the situation with wood, plastic mug filled with water, etc. Coming to the third situation, when the buoyant force is greater than the weight. So since the upward force is greater than the downward force, the body will float on the surface of the water or remain partially immersed in the liquid. So this happens with a cork or wax. Now the law of flotation, that's how states that weight of the liquid displaced by the immersed portion of the object is either equal to or greater than its weight. So this is going to decide whether the object is going to float or sink in a liquid. So it is clear that object placed in a liquid will float only if weight of the liquid displaced by its immersed portion is equal to or greater than its weight. So this is called the law of flotation or the principle of flotation. I would like to tell you at this point that flotation is also related to the density of the object and that of the liquid. So if density of the object immersed in a liquid is less than the density of the liquid, then the object will float partially immersed in a liquid. If density of the object immersed in a liquid is equal to density of the liquid, then the object will float fully immersed in the liquid. And if density of the object immersed in a liquid is greater than density of the liquid, then the object will sink. Certain situations are quite easily understood by relating to Archimedes principle and the law of flotation. As you can see that a ship made of iron floats while a piece of iron sinks, because ships are designed to have a hollow structure. This structure gives a ship much bigger volume for its weight. So when a ship enters water, it displaces a large volume of water. As a result, the ship sinks in water until the weight of the water displaced by the immersed portion of the ship becomes equal to the total weight of the ship. Therefore, a ship floats on water. Similarly, icebergs also float on the seawater because ice is lighter than seawater. About 1/10 portion of an iceberg remains above water, whereas 9/10 portion is inside the water. A balloon filled with hydrogen gas rises up into the air due to the buoyant force exerted by air on it. It is easier for a man to swim in seawater than in fresh or river water because seawater contains many salts dissolved in it. The density of seawater is about 1.03 gram per milliliter, whereas that of fresh water is 1 gram per milliliter. As a result, the man's body experiences greater upthrust in seawater than in river water. Therefore, it is easier for a man to swim in seawater with a smaller portion of his body submerged. So these are a couple of examples that we can understand with the help of the concept of Archimedes principle. So that will be all for this lesson. Thank you.